I wanted to make this video to kind of to show the different aspects of was one particular aspect of NextRad Doppler radar. Stands for Next Generation Radar, that we've used since the late 80s in particular on a national scale here in the United States. There's a precipitation mode, which is when the mode that the radar's in when there's precipitation around, particularly rain. Sometimes they'll have it on when there's snow as well. But this clear air mode is when there's no precipitation within the range of the radar, or very little. In other words, not of any significance. It's a more sensitive mode. But it doesn't update constantly like it does when they put it in what we call the swales mode, where they can update every minute, every 2 minutes. And it, of course, requires more computing power and less radar sensitivity. So when they put this into the clear air mode, the radar becomes super sensitive. And the Louisville radar here in this example is exactly what we're seeing here. And when we mean it's in a very sensitive mode, I mean, it can pick up just about anything. It can pick up particulates in the atmosphere. It can pick up just water vapor, fog. In some cases, toward the ground, when it's happening toward the ground level, and it can even bounce off buildings. You can actually see these things bounce off buildings, and very close to the radar, particularly if there's an interstate nearby, which in Louisville there's several near the radar site there. It can pick up extra activity, which are nothing more than the very sensitive radar beams bouncing off cars. So that's what we have here. Because if you look at this, you're like, wow, that looks like a fireworker. Well, that looks like some type of weather modification or something going on here. And that's not what's going on here at all. There's nothing of that nature going on in Louisville whatsoever. Matter of fact, this radar view is for a very nice day coming up in the Louisville area. But you can see here, look at all the rays bouncing off, and it's because the radar is super sensitive. And it almost looks like there's rain near the radar there. Well, no, there's nothing there. There's clear skies. Matter of fact, I think the Indy radar probably might have this too. Okay, the Indy radar is in precipitation mode. You can kind of see the difference. You still see this kind of pie-looking pattern around it. And that's also because temperatures at night, when the temperatures drop, the temperatures get closer to what we call the dew point temperature. In other words, the dew point temperature is the temperature that the air has to cool to form a dewdrop, or basically moisture. And so at nighttime, when the temperature and dew point are pretty close together because the atmosphere is cooled with the loss of daytime heating, this is what happens. And I want to show you something else in this image here, even in the precipitation mode, that's interesting. This is it's a little cloudy up here where I'm at right now. I'm actually not far from the Indianapolis radar, but there's no rain. Now there's rain up north there, so toward Logansport. You can kind of see right there. It looks like there's kind of a beam, looks like it's sliced there. Well, that's been there for years, and what that is the radar beam bouncing off the skyscrapers in Indianapolis. That's exactly where that comes from. And then see this up here? Looks like it's not moving. Looks like a shower or a storm. It's just not moving. Well, that is a wind farm. There, particularly if you go up into northern Indiana and all the way up in here, there is a series of wind farms up in this area, and the radar beams can bounce off of those as well, and the moisture that's on them when the air cools off at night. So it's not weather modification, folks. This is a simple radar 101. Thank you.